Welcome back. In my previous video, I showed you how I took this engine, which is a model train engine made by LGB in G scale, and I showed you how I tore it apart and redid the whole gearbox with parts that came from this new gearbox. So just to give a quick sum up of what I did, I took out the brushes that were in here, I took out the motor that was in here, and put them into the older unit. And while I had this apart, I completely sanded down the bottom of the shoes, I sanded down the inside of the wheels where the brushes contact, I re-greased the whole thing and cleaned it up completely. And the reason why I did that was because the original motor that came with this was just really heavily used. Even the traction wheel wasn't in great shape. You can see this is the replacement one as opposed to this one here, which is pretty shot. I'm going to save this as a spare still. It does still run, but again, not that great. But I am going to use this now. And this particular unit runs really nice. I tested it out in the rails. And after I got done with, or during the film I should say, before I go into there, I mentioned that I want to put lights into this and use one of these buck boost converters to keep them at a steady voltage. But I felt like after I got done taking this whole thing apart and redoing the mechanical part of it, I didn't have enough time in that video, and I said I would do a second video with just the electrics, and that's what this is going to be. Now I did manage to get this thing apart further than I initially did in the original video, and you can see this cab is completely bare. There's no lenses in the back here anymore. I took the handlebars off, I took the glass out, which is this guy right here. Little quick story, this was kind of a pain in the butt to get out because you can see there's a little bit of a profile on these pieces and they snap into these holes, so you actually have to stretch this out a little bit and pop this out. Putting it in is going to be the reverse of that, so that's going to be pretty tricky, but nonetheless I felt it was a good idea to do, because before this sounds bad, this came from the house of a smoker. And I know that because I had this funk all over it. And it must have sat up on a shelf in their house, and, you know, not to sound bad because I am an ex-smoker, so I know what that cigarette smoke does to things. And this isn't a knock to anybody who smokes, but nevertheless, some 91% isopropyl alcohol and my old toothbrush that I keep in my drawer here for scrubbing things, and a couple paper towels, and even some little cotton swabs really did the trick and got this thing looking brand new to my eyes. I mean, this thing, I don't want to say it was filthy, but it wasn't in the cleanest of conditions, and you can see like even the roof, it had like this white film kind of thing on it. And that was after my initial cleaning when I first picked the thing up, and that was actually just using regular 70% isopropyl. So the 90% definitely made a difference. But you know, this whole thing just snaps together relatively easy. It kind of it's like a puzzle. One piece has to go in first, and in fact this car over here has all the remaining plastic pieces, like the grab bars and the handles and the bumpers and the lenses and all that stuff. One thing to note, this railing piece, which actually goes along the top of the engine compartment here, the other one had snapped in two places, so it was kind of just like free spinning out in the wind. And I did initially try to repair it with just your standard cyanoacrylic glue, like super glue, but I found it didn't hold because super glue has, you know, a little bit of a brittle property to it, and you need actual like model cement that's really going to bond the pieces of plastic together. And unfortunately, you know, it's been a long time since I built one of those models, so I don't have any glue that's good. So before I do put this together completely, I will have to, you know, re-glue the whole thing the proper way. And also I want to get myself a black paint marker and just touch up the dials in here and just add a little bit of color to it, and maybe some other spots in this thing just to make it look a little more authentic, I guess. Some of these other engines have a lot more detail, and this was a starter engine, and I do actually have two other starter engines that, you know, and then when I say starter engine, I mean it came with a circle of track, two cars, the engine, maybe a couple figures like this guy, and a little transformer, and obviously the wires. I have one for my original starter set, and then I bought a second locomotive because I have enough cars where I can actually make a couple different trains out of it. But this particular starter engine really wasn't that detailed. So I'm going to do things like paint the smokestack. I might even drill a little hole out of it. You know, this is a diesel engine, so it doesn't have a giant, like, actual smokestack. It's just more like a, you know, exhaust pipe. But I will detail this a little bit more. But the point of this particular video is the actual electronics part of it. And I have my breadboard out. I have my second buck boost regulator, because I decided to buy two of them because I knew I would be putting one into a project, something like this. And well, here's that big lead weight I mentioned too. I don't have a scale, but this thing's got a lot of heft to it. This is probably the heaviest piece out of this whole equation. In fact, I'll be willing to say that the motor unit, all the plastic, which plastic's not heavy, but this is some pretty thick, good quality plastic, all that put together isn't anywhere near the weight of this piece alone. So when this is in there, you've picked this engine up, you're like, wow, this has got some heft to it. That's why. So what I'm going to do is I'm going to pause the camera, and I'm going to draw up a quick little sketch of what I want to do. I'm going to consult with the LED Wizard, which is a online website that you can put in the forward voltage and the current requirements of your particular LED, and it'll tell you which resistor to use. And they actually have a series calculator. I've done these before in the past where I've used like three LEDs with one resistor. So I'm thinking we're going to put 3 LEDs back here with one resistor, and then the front there were 2 lanterns here and then one in the middle that will also do the same treatment to. And we'll go from there. Now I'm not sure if I'm going to set this at 5 volts or if I'm going to set it at 12 volts. Now at maximum voltage on the rails, you're putting, you know, my supply will do like 21, 22 volts. I know a lot of the ones that came with the system use 24 volts. So I'm thinking cutting that down to 12 volt would probably be the smart way to do it. And then likewise boosting from the lower voltages up to 12 volt would probably be better than having to go to 5 volt. I mean, it's a sweet spot. One of the things I have to experiment with too is whether or not I'll need a diode, because I'm not sure what this thing will do once you pump reverse voltage into it. So I think we'll just put a diode into it, because I only really want the front lights on and the rear red lights on when this thing's going forward. And since this thing doesn't actually have a lens or any kind of light in the back for when it's going the opposite direction, I'm pretty much going to leave this as a forward only, you know, engine. Very rarely, in fact, I don't think ever have I decided to, you know, put this in reverse, and instead of having it pull the trains, having it pull it from back, because after all, the engineer is facing forward. You know, you'd have to turn him around the other way for that to make any sense. It kind of looks just silly, this thing going backwards, but I digress. So let me go ahead and pause the video here, draw up a couple sketches, consult with the online wizard like I mentioned, and we see what we can put together here. Alright, I went ahead and used the online calculator tool as well as the Electronics 2000 software that I have on my computer here. I will put the link of both of those in the description. I mentioned in a previous video that the Electronics 2000 software gives you a lot of different things like power calculators and resistor code, you know, lookups and stuff like that. So it's a very handy program to have on your PC, especially if you're just getting started with electronics. But what I had and did was I plugged a couple different values into the calculator to find out what I needed and what I can do or not. Now the red LEDs with a forward voltage of 2.0 to 2.2 volts and a forward current of 20 milliamps. At 5 volts, we'll need a 150 ohm resistor for one LED, and that's going to dissipate 60 milliwatts of power. But 3 LEDs we can't do. The calculator gave me an error, tells me I don't have the right kind of input voltage. So I tried it with 12 volts, and I found out that I need either a 510 ohm resistor for one LED or a 300 ohm resistor for 3 LEDs. And being that I decided to go with 3 LEDs, I think that's the way we're going to go. And the best part about that is the resistor is only using 120 milliwatts of power as opposed to 200 milliamps. On the white, it's pretty much the same story. We can't do it with the 5 volt, but the 12 volt works fine. Now that one, we have a little bit of a wider voltage range from 3.2 up to 3.6. On both the red and the white, we're going to go with the lower voltage setting. That way, we're not putting the full voltage into the light. They should have a longer lifespan. Not the LEDs don't have a long lifespan. And the online calculator actually gave me the schematic view, which is pretty simple. We're just going to connect the positive voltage to one side, connect the LEDs across in series, and then put the resistor on the negative side and connect it to ground, obviously. Now some people put the resistor on the positive side, some people put on the negative side. I've always done it positive, but for the sake of the argument, we're going to go with the negative side and just follow the schematic here. Now, this entire array in the red or the white will both draw 20 milliamps. So those two added up, plus the power consumption of the actual buck boost converter, should be less than that 1 amp mark that I have, the 1N4007 diode. And I'm pretty much sure I'm going to put the diode in line with the positive input of this buck boost converter, so when the current switches to the other side and makes the train go in reverse, this thing will just shut off because the diode will cut the power to it. And that's kind of the intention that I have. All right, luckily enough, I do have everything I need. The resistor here is the 120 ohm resistor, and that has a color code of brown, red, brown, and then the gold indicates that it's a 5% tolerance. And then the other one here is orange, orange, brown, and that's the 330 ohm resistor. And I did look and see I have enough white in either the 3mm or 5mm, depending on which ones fit better. And then I also have unfortunately only the 5mm on the red, but if I hit that button you can see they all light up, and I've already tested these. So we do have a bunch of working LEDs, which is always a good sign. So then the next thing is assembling the circuit. So I'm going to go ahead and I'm going to plug this all together. Breadboards are very simple. These strips are all connected in a line. So maybe if I could zoom in a little bit, I could show you this. If you don't know how a breadboard works, you know, this is just a quick rundown of it, but I have power coming in. I actually have 5 volts from my power supply coming in at the top up here in these 2 plugs. Obviously red's positive, black is your negative, or ground. And these 2 wires that come in here power up this rail, and this rail goes the whole length and powers it the whole way. So this red strip indicates that's the, you know, positive voltage. The blue strip indicates negative voltage, and that's the whole way right down the middle. These strips along here, which are numbered from the top all the way down to the bottom, they're connected this way, and this little gap in the middle separates them. So if you put a IC chip and straddle it over it, all the pins this way and all the pins that way will connect to it. I'm probably not explaining that the best way, but that's just the way I think of it. So if I want to connect something to negative, I have to take one of these little jumper cables, like, let me get a shorter one here, like this resistor here. If I want this to connect to the negative rail, I have to actually jump this little gap over here, and this resistor here. So now this is all in line with each other, and then I have it jumped over here to the end. So I'm actually going to take the red LEDs, which are in here, and on an LED, the longer lead is the positive, the shorter one's the negative. So I'm going to stick the negative one in like this, and then you can see, I don't want to connect the LEDs together in, you know, in series. I have to connect them together, you know, positive to negative. So the next one I need to connect is this one here. So I'm going to take the positive lead and connect it to the negative lead. So like I mentioned, the shorter one's the negative, that's connected to the resistor. So now the next row over, I'm going to go like that, and then I'm going to do the same thing with the third one, and it's going to be negative to positive like that. And then I need another little jumper here. Let's go with this one, and that's I'm going to connect that rail now to the positive rail. Actually, I get a longer one. And if I did it right, still longer, bear with me a moment. If I did this right, which hopefully I did, I'm pretty sure I did, this array should light up, which it is, although it's really dim. So that means I just have to adjust my resistor code. But then again, I don't really want this to be super bright. So if I take a look at this again, just adjusting that resistor is going to make these light up brighter. And like I said, this is a 330 ohm, so less resistance should make these brighter. So I'm going to go back to the calculator and I'm going to rerun the numbers with the forward voltage of 2.0 and see which resistor that tells me to pick, and we'll see if that makes them any brighter. And of course, my error. I actually mentioned that this thing is being powered off of 5 volts. That's not what we want. We want 12 volts. So I'm going to go ahead and just fix that right now. Yeah, there we go. Yeah, it helps if you have the right value. This whole time I said 5 volts wouldn't work, and that was why they wouldn't light brightly enough. But you get the idea now that that's what we want. So I'm going to go ahead and repeat that process down here with the white LEDs. First I'm going to try that with the 3mm. Now sometimes when you use these boards and you haven't used that particular hole for the first time, they do kind of tend to stick in here. So let's see. Connect the positive here. To the positive rail, and get another little jumper here and connect the negative rail to that resistor. And there's the 3 white LEDs, and they are still pretty bright for the small ones. Now what I wanted to experiment with was maybe using 2 small ones and 1 large one, so let's see if that'll work. They should all have the same forward voltage and the same current draw, which they do there. So yeah, I might just go ahead and use that too, maybe 1 big one for the middle and 2 smaller ones for the side lights. And this is what the same circuit looks like now, but I've just put a diode in line just to show you how they work. Now on a diode there's a little strip. You might not see it on the camera zoomed in the way I am, but it's a black body, and one end of this body has a silver or a white, like what some people call a racing stripe, but it has this little stripe at the end of it, and the current will flow from the side without the stripe to the side with it. So here you can see the voltage and current and whatnot is going up this diode, through it, down this wire to the positive side of this array, through the resistor to the negative side. And if I flip this thing around, it won't light. And that's what we want. Now this is actually going to go on the buck boost side of it, on the input. And that's going to be the next thing we're going to have to test out in this circuit, just to see if we can get that to work. So since we're going to go with a maximum of up to 20 volts, I'm going to connect this directly to my transformer here, and we're going to test that one out, and then I'll hook it to these arrays, and that's going to give us the answer that we're looking for here as to whether or not this is going to work. I went ahead and connected my meter to the buck boost converter. I put the diode in line with the positive input, and I have it just connected right now just to the 12 volt power supply, and right off the bat it was set to 19.9 volts. So I do need to adjust this with a screwdriver, and we're going to get this down to exactly 12 volts, and then I'm going to run wires over to the breadboard here, and we're going to attempt to light the entire circuit up off this buck boost converter. Once I feel confident with that, I'm going to run wires over to the larger power supply here, and we're going to pump the full voltage into it, and we'll see at what point do these lights light and what point do they not light. And then once I get to that point, I'm probably actually going to cut the video for tonight, and it's getting kind of late, and then I'm going to actually come back to this tomorrow and figure out how to get this to actually connect to the main power here. Now, as far as I could tell, on this particular unit, this green wire here is just jumping the rail, input rail, to the motor, and the other pin in here, which is vacant right now, is already connected to the motor. So if I pull this out, it won't run anywhere. So I'm going to have to figure out the best method of connecting two wires in here, because I don't have any of these little crimp ends to fit onto these pins. I'm ideally just going to snip this wire in half here and just connect it that way, but that'll be tomorrow when I come back to it. This will all be shot obviously in one episode, so don't worry about having a part 3 to this. But at any rate, let me go ahead and adjust this. We'll connect it to the breadboard and we'll see what we get. And this is what I'm going to call the proof of concept and the ending point for this moment. I have 1.99 volts DC on my meter. It was actually 12.00 on the nose before I connected the LEDs, but regardless, it's right where we want it to be. I have the 1N4007 diode coming into the input of the buck boost converter. The output of that is connected to this strip right here, which the positive of the red and the positive of the white arrays are connected to. The negatives are ran through their respective resistors and then referenced back to the negative rail. And I figured out that the negative rail on the actual circuit here is the same as, it's not independent, whereas the positives obviously are. So I don't have the positives, the negatives of those arrays ran back to the buck boost converter, just the positive, and it works. Now this is with a 1.6 volt input. If I go up here and disconnect this from my power supply and plug it into the 5 volt supply, you can still see we are still getting 1.99 volts. The lights have the same intensity, and we'll go one step further and we'll connect it to the 3.3 rail here, which isn't enough to power this. So that's going to be the kind of cutoff point. The best way to test this would be to put it onto the actual power supply and see what we get out of that. I guess I can do that real quick before we actually call this a quit for now. And here we have what I'm going to call the moment of truth. I have everything lined up. You can see over here we have a black jumper cable connecting one of the rails right over to the breadboard. Same thing with the red. I have my meter connected up the same way. And what I'm going to do is turn on my power supply here. And we have no volts going to those rails right now. We already know this is set at 1.99, so I don't need to keep this metered. But as I start to turn this up, we're at 2, 3, 4, 5, 6, 7, 8. We got nothing. Now the reason why is because we're running reverse technically right now. The train would be going backwards. If I lower this right back down again and I switch it over to positive voltage so the train runs forward, as I start to turn this up, we can see that when we get to maybe 4 volts, I'm going to take a guess, and right at 3.9 volts those lights come on. and we can crank this all the way up to the full 21 volts and they stay the same, you know, intensity, which is exactly what I was wanting us to do. I'm going to go ahead and just set the train on here, and hopefully we can get that to move. And it is going, and the lights are lit, and it's going at a pretty slow speed. So that's exactly what I wanted to happen. The ultimate test is going to be putting this into circuit form and slapping it into that train and see what happens. Now, I know the minute that you reverse this to the other way, it doesn't light, obviously. So we're going to have to, you know, work this just right, so when the train's going forward, these lights light. And that's going to be a combination of how the transformer is wired to the tracks and which pin we determine to be negative and positive on this particular truck. So we're going to cut the video for now. I'm going to go to bed, and tomorrow morning when I get up bright and fresh, this will be put together into a circuit that will hopefully work the way I want it to. So it's pretty much going to seem like when the train travels in a particular direction, it's going to go the way we want. So when it comes this way, those lights are going to light up, and when it goes the other way, they will not light up. See you tomorrow morning. Alright, tomorrow is now today, and I've been kind of playing around with this a little bit to see what we can do. One of the things that I did earlier this morning was to do a little bit of touch-up with a really thin permanent marker. And you could see I did drill that hole out that I've said I would do in the little stack here, the exhaust pipe, whatever you really want to call it. And I painted it black with the marker just to, you know, make it stand out a little bit. And I also went ahead and did the cab as well. Just did it with a little bit of red and black. You know, it's not the best job, but it's going to be inside the cab. You're not going to really see it too much, but I wanted to have something on there. I also drilled out the holes. First I started with a very small drill bit just to draw a pilot hole, and then I used a larger bit that was just the size of the 5mm LED. Then I used a round file to just really get in there and make sure the lights fit. I even had to use a razor blade in the inside here just to get the sprue out of the way, the little bits left over from the drill bit. And when I popped in one of the 5mm LEDs here, I noticed that it protruded just a little proud of the lens area. So I actually had to sand it down. And I'll actually show you the difference between the two here. You can see this one over here is the one that's sanded compared to the one on the other side. And also when you sand it like that, because it's not clear, it kind of diffuses the light a little bit, which I thought would be a good idea. Now I have a couple different pieces of sandpaper here. This is actually model sandpaper for making models. I think Testers makes it. You usually get one of those like hobby kits. But I just use this to try to give that as smooth of a surface as possible. And it actually looks pretty good. So I need to do that to the remaining LEDs for the back area here. I also went ahead and figured out how to mount the LED inside of the front facing lantern. Now this was actually really tricky. I ended up using that small drill bit, and I drilled in from underneath, and I went straight through to the bottom here, and then I kind of like went on an angle and used just a slightly larger bit and just you know, elongated the hole. And then what I had to do was take the LED and bend it slightly, kind of like this, and like curved, and then that allowed me to feed this in on an angle. And I also used a very small piece of heat shrink tubing on one of the leads because they kind of touch together. And now that I got that centered, I'm going to go ahead and use some hot glue just to hold it in place and just kind of filling around it. And I also had to do the same sanding routine on that. So I'm going to go ahead and do that to a couple other ones here. And we'll get that part situated. Then we're going to go ahead and start designing the circuit board. Alright, time for a little update. Since I've kind of been quietly working here doing this and realized I haven't really done much with the video, but what I did was took one of these perf boards that I mentioned earlier, and I soldered in the 2 resistors, and I wired them over to what I'm calling the negative rail, which is this piece over here. And by the way, you can tell that the pieces on here that are, you know, outlined in white are connected to each other. So this strip's one piece, this little L is one piece, and so on and so forth. So I basically came out of here with the negative and made this a one rail, and then the positives over here is the other rail. And if we follow this over, you can see this is that diode that we used before. I just put a little piece of heat shrink over it just to keep it nice and clean. And these are those connections that need to get connected into the train here. And I did this so I know which ones go where. I've already tested this out. Now I want this side to be the front facing part of this truck. So I need to put these on this side and this on the other. And this is the rail that comes directly off of this side and connects to the motor. And the same thing on this side, which is actually this pin, and then it connects to the motor there. So in order for this to work, you have to jump these 2 pins, which is what this is doing here. That's why it's got this fork in it. And these connectors are actually the connectors that came off of the extra motor that I had. And I just cut the light off of it. Now the wire in here is the stiff wire, as is this, but the wire I'm actually going to come from here and go to the LEDs is going to be the flexible cable, just to make it easier to, you know, fit through. A couple of things I'll point out too is these little points here prevent this from actually seating all the way in, which is what we want. The way this is designed, it's actually got some pretty good tolerances. You can see this wheel just fits up in there perfectly. But what I did was drilled a hole right here for the wires to come through and pass out underneath the lead block, which sits on top of these posts. And this will sit inside the engine cavity. And I've actually, you know, used this so I can actually bend this or, you know, mount it any particular way that I want. That made it a little bit easier. In fact, I probably will put some double stick tape on both sides of it and just physically mount it right side of the actual engine housing like this, right up against both sides. Probably actually face this way, so these wires here can just get fished through that hole, passed into the block underneath here, and get plugged into the motor. And I've also noticed right where Mr. Engineer is standing, there's a couple holes already in the ground, or the floor I should say. And when I put this cab on here, you can see that those holes line up in there perfectly. And they're actually inside this block as well. So those wires are going to fish along in here and poke back through that hole and then come up into the engine compartment and kind of make this nice and neat. This is going to be one of those things that I think once it's put together, it's probably not going to come back apart again unless I give it some extra wires or whatnot. So I'm going to have to figure out how that's going to happen. But I do have a lot of room in there to play around with, luckily. I mean, once that lead block goes in there, it's going to give me a little bit less room. So I'm going to have to see exactly where everything's going to get placed. Also, unfortunately, while I was kind of just messing around here with some stuff, I broke one of the red LEDs. This is the replacement for it. What happened was I had this wire bent right up against the back of the LED, and it caused too much stress and it snapped on me while I had it in helping hands. But this is actually just you know, the red LED with the sanded down top on it, and I put the heat shrink tubing on it just to keep them from shorting out since they are so close. But at the end here, they're actually going to bend outward, And then I'm going to take the other LEDs. You can see I got it set up like this. This is going to connect on here and get splayed out that way, and the same thing with the other side. And then I'll come with a positive one side and negative on the other and run them back to the block that I mentioned before. Also, I tried to put a little bit of hot glue inside here, and that actually proved to be quite messy. They're pretty centered right now. What I actually ended up doing was taking the LED out, putting a drop of glue inside first, and then stuck it back in, and kind of before it cooled, just wiggled it and got it just the way I want it. And I decided I might not put the lenses back on, because if you remember, the red lenses like this were clear, but the white lenses were just a white, you know, opaque kind of lens. And when I stuck it back on here, it lit up, but it didn't provide any forward light. And not that this one does, since I sanded it down, but it was a nice little point of light. These LEDs are actually made of an epoxy, and from watching other YouTubers and just playing around on my own, it is true that when you fill stuff with epoxy and stick an LED into it, the LED kind of just disappears. This clear part will just kind of meld into the epoxy. So I decided what I'm going to do is before I call this a finished project, I'm going to actually get some epoxy and just carefully fill in here and try to get it level and make this a completely solid unit that, you know, once you do that, this is going to light up. The whole thing will you know, have that epoxy look, and that roughed over front end here, that should disappear too. So this whole thing will be effectively like one big LED with a point of light in the middle. I still haven't figured out how I'm going to do the forward facing light that's going to sit up at the top. I have actually gone online and referenced the missing piece, and it is a, you know, big dome style, you know, lens that a regular bulb would sit into. So I might just either find one of those used on eBay someplace, because I know they exist. There's places who have all those little parts. Or, like I said, if I ever get a 3D printer in my hand, I'll design one and 3D print it. But for now, since this has to kind of go together as a complete project, what I'll end up doing is just running the leads up to it and just throwing an LED on it for now, and just kind of like bend it over the edge here. I did take the larger 5mm white LED that we had in the series before with the smaller ones, and believe it or not, I stuck it in the end of my drill and spun it onto the file, so the edges here are completely opaque, but the front of it is shiny. You can actually see the light reflecting off of it there. Quick little note about the white LEDs: they have a lot larger of a reflector than the other LEDs do, so they kind of like spread the light a lot more. Whereas, you know, the white ones and the red ones and the other colors, they don't have such a big one like that, which is kind of interesting. I've actually seen some of the older white ones like this. They didn't have such a large emitter, and they didn't really throw the light as much. But, you know, this is what I got going on right now. It's kind of boring sitting here doing this to the viewer. To me, it's quite fascinating. It's amazing how fast time goes by when you get in really into this kind of a thing. But it's not something I can actually go ahead and start recording a bunch of it, because it's just too much. It's too much trial and error and figuring things out. But nonetheless, I'm making pretty good headway now. I did actually test this out. The train is always going to run in that direction. If I wanted to run the other direction, you know, if I had a layout, I would actually have to switch the power leads, which is not a big deal. You know, I guess when you're running these controllers, forward could be backwards and backwards could be forward. It doesn't really matter. I just always looked at this controller and thought this was forward and this was backwards, because it just, you know, kind of makes sense that way. But I guess, you know, it really doesn't matter. So you can, you know, do it any way you want. I'm pretty sure the other units that you know, have the auto reversing lights in it, have some kind of a diode system set up on both sides, so when it goes forward one set lights, when it goes in reverse the other set lights. But like I mentioned, since they give you so many red lenses in the back and nothing here in the middle, that was kind of a moot point with this particular model. So I'm going to go ahead and keep playing around with this a little more, and we should hopefully have somewhat of a working model within the next hour or two of my time, and probably within the next couple seconds of your time. After doing a dry run, unfortunately I've discovered that the leads that I had coming off of the main board here were a little too short, and not to mention using the stiffer wire made it harder to route them. So I went ahead and kind of undid the whole thing and actually took some more of these ends, as you can see here, and actually soldered them on like I did before, crimped and soldered, and I also put some heat shrink on it just to keep them isolated. They look a lot better than the original ones did. And the jumper, I just went ahead and jumped it, you know, just like the original one was, and then came back out of one of the terminals here and it went back up to the diode, and the diode's actually now mounted really close to the board, and the flexi wire makes this a lot easier to maneuver. And I actually noticed that I can put this inside here, no problem, right up inside, and where this sits right here is where the lead weight actually pushes up against, so the clearances are like dead on. I couldn't have gotten any better than that. And I also noticed that there was a slot up here in the front that the wires can just easily pass right through, and that's going to fit a lot better. I might have to widen it just a little bit, but they're going to fit through, and then this is going to snap on. Definitely better than it was. So that's definitely better than how I originally had it. Sometimes, you know, when you go to actually do the dry fit, that's when you're going to realize that these things don't go in the way you thought they would. But you can actually see, you know, that looks really nice with the heat shrink on it. Very happy the way that's coming out. And I did leave the stiff wires here because I kind of want them to sit like that. In fact, I'll probably give it a little more spring so it just pushes against the sides. A little piece of tape on both sides of these is just going to hold this right in the spot. I didn't mention before, at least I don't think I did, that I did look up the 555 circuit, and the schematic says that I can actually run that at 12 volts. Unfortunately, I looked at my parts bin, I don't have any of those. So eventually I will have to get one and the relevant parts to make that thing work. And I will be able to put a couple lights up at the top here of the cab. Probably on these little flat spots, most likely, if not just in front of them. I'm going to drill the two holes out. I'm going to put the two amber lights in it. But that's going to be something down the road. I probably won't do that, you know, right away, obviously. So I'm going to, you know, continue plugging along at this, and next update I should have will be the red LEDs mounted in the back of this cab unit. I'm pretty much almost there. I just have to just hone in exactly where they're going to sit. In fact, I got some of them already trimmed up, ready to go. The only thing I haven't accounted for, and I'm probably just going to use the black liquid electrical tape that I have, but the light will leak out from the back of these a little bit. So putting a dab of black, you know, glue on the back of that, the black liquid electrical tape, that's going to prevent that from happening. And I'm probably going to have to put a little of that up here just to hide that one wire that you can see shiny in there. Other than that, there really won't be too much more to do. Just like I said, just keep plugging along on this and get it ready. Here we can see the red array ready to go. I used the green wire in place of a black wire because I don't have any. My spools are kind of getting low. Unfortunately, I don't have a Radio Shack nearby to go buy anymore, so it's kind of a mail order thing at this point. Anyway, everything is nicely heat shrunk, as you can see. I mentioned before that this is just a single copper wire here, you know, just the solid wire, so I can kind of position these the way I want, and the rest of them here are the stranded wires. And I gave myself enough room to, fish this through. Now before I actually attach this to the back of the cab, I'm going to go ahead and hit the back of this up with the liquid electrical tape, so I don't have to worry about doing it while it's inside the cab. Then these wires will just get fished through the floor, and that's going to be easy. The harder part's going to be getting the wires into this little front lantern. One is going to have to come from the right, the other one's going to have to come from the left, and I'm going to have to figure out a nice way to get those in here. I might actually just snap them on here now and go with it from there. I'll probably end up wiring the two of those to each other and then go to the front light. Or another thing I could do is actually undo the 120 ohm resistor that I had put in place originally and figure out which one I need for 2 lights instead of 3 in the array. I mean, that's always a possibility too. And just leave 2 in the front and 3 in the back like this. And then later on, I could always, put the front facing one on. Still things I'm kind of deciding on the live here. We'll see what happens when I figure that out. It will take a little while for the liquid electrical tape to dry, so I'm going to go ahead and get that started now, and I'll come back to that when that's ready, and we'll get the front lanterns mounted. All right, making some good progress now. I have one of the lenses in the front here mounted, and the best I could do was get 2 pieces of heat shrink tape on there, or tubing, and run it through. And I have the red wire coming through the top up here, and this is just just to give me some extra slack so I can figure out what I'm going to do with this. And then the one here is going to run to the board, and I'm going to do the other side right now, and then all I have to do is mount this whole circuit board inside of here, and it's going to be pretty good. I do have the electrical tape, the liquid electrical tape, drying on the red lights, and that's coming out pretty good. And the stuff that's in here has already dried pretty well. So once I mount that, I did have to actually drill a hole here so those wires could pass through. And once this is mounted, which I'll show you, I also snipped off the corners here with my snip tool. That's pretty perfect. You can see it just runs right underneath that box there. That's the best I could do it. I couldn't think of another way. I mean, like I said, this wasn't intended for lights, so all things considered. I think if it did have a light, it actually would have came out this stock hole right here. And given that there's provisions for wires already here, that makes the most sense. But anyway, I'm going to continue on the course I'm on because it seems like I'm making pretty good headway. And it has been a few hours since I initially started recording this video tonight. And that's the good thing about editing. I can go ahead and cut out the boring parts. Actually, I'm not really editing this. I'm just kind of starting and stopping the recording as I need to. But you get the idea. So yeah, looks pretty good so far. I managed to get the whole bench cleaned up, and I had to actually clean off my memory card because I ran out of room. But you could see I got the engine kind of dry fit together just to see how it's going to look. And I decided to just prop it up over here off the tracks. It doesn't run all over the place. But if I fire up the transformer, you can see the wheels are moving over here. And when you get to just about right there, those lights come up, which is good. That's a pretty good speed. I did test it on the track, and it moves at a fair clip before they come on. It'd be nice if you could just have them come on right away, but for that to happen, I need to get a different circuit, one that runs off a lower voltage, or find a way to boost the circuit, the voltage coming into it, which I'm sure there's a way to do. But if I go ahead and turn this around, hopefully without losing my alligator clips here. Let's get this set back up. You can see there's the red lights in the back, and obviously the front lights. and it does actually fit really well. There's just a little bit of light leaking through the cab, but that's okay because there's no lights in here now, so I guess that's gonna give it some kind of light. I gotta be careful because everything is just barely connected here. See if I can do this without. You can get an idea how that's sitting in there. You can see the lead weight. Eventually, if I get the 555 timer and I build a circuit on the breadboard, you might have flashing lights in this thing too. But for now, this is pretty good. Certainly better than it was. I'm not sure why the wheels are making so much noise though. That I have to take a look at. I might have to do a little bit more lube work on it, but all in all, I'm pretty impressed with this project. That's about all I can really add to it this particular video. So with that, I want to thank you for watching as always. If you're not a subscriber, please subscribe. That really helps build the channel. Last I looked, I am very close to 60 subscribers, and hopefully we can get to that 100 mark before the end of the year, which I still have quite a ways to go yet, which is excellent. If you are a subscriber, I want to say thank you as always for subscribing. That really means a lot to me. Be sure to give me a thumbs up or a thumbs down. If you decide to give me the thumbs down, please leave a comment as to why. That's going to help me improve this channel. And don't forget, you can also find me on Facebook at www.facebook.com/PeleggiTech. I will have a link in the description below. Well, thanks for watching. See you next video.